Going to be a rather strange video, assuming I can assemble everything correctly, because I forgot to start recording at the very beginning of class. So now it is currently after class, and I'm going to go through all the output and give some explanations. Since I have all of the output in my Matlab window, I won't have all the details, unfortunately, but I'll do as much as I can remember. And then I'm going to take the last 15 minutes of the class, which I did record during class, and add that onto the end of this video, so we'll come as close as humanly possible to having the full experience. My apologies, and I'll do my best and hope to start recording at the beginning of class, and but I appreciate any reminders to start recording as well. So here we are at the start of a MATLAB session. I'm just going to go through this. Um, so um, so the question was asked about um, removing or getting rid of a diary, and really the only way to get rid of a diary, fortunately, is to explicitly remove it yourself. You can remove a diary file in Finder on a Mac or Windows Explorer in Windows, or you can delete it from within MATLAB. So as an example, I've okay. Here I've used the clear command to clear any variables that I had at the time, and that removes them from a workspace that's down here, and I'll talk more about that command a little later. So then what I did is I started a diary for today's class, and then I just created a couple of variables, and then turned the diary off, and then I can use the delete command from within MATLAB to delete the file. And I needed to do that earlier because I was in the wrong directory. I was in the Matlab folder before. I needed to be in my Math 460 folder. So then I used the cd command, change directory, to change to the Math 460 subdirectory. And now I'll start my diary again, and that diary is written here. So then I go ahead and create these variables. And if I want to save variables in a file so that I can retrieve them in a later MATLAB session, the save command is used for that. So if I type save space variables, that will create a file that you can see here called variables.mat, short for MATLAB, and so all the information about the variable, its names, its values, are stored in there. So then if I type clear, then those variables would disappear from the workspace that we see over here. And then I can use the load command to load those variables back into the workspace. So when I typed clear earlier, everything disappeared. I typed load again, and then these variables x and a were brought back. Now, keep in mind, a .mat file is not a text file. You can't edit it like in Notepad or Word. It's a binary file, so don't try that. There are options for load and save to work with plain text, but it makes the commands less useful. I tend not to use them. Unless I get like a text data file from somebody else that's created some other application, then I need to import that data in. That's the only time I would use those things. So I won't talk about it any further here. The clear command can be helpful to free up any memory used by whatever variables you have, especially for any large matrices or long vectors. But as you can imagine, a very destructive command. You don't want to use that unless you are sure that you want to get rid of those values and variables you have. So either you don't really need them anymore, or if you've saved them, then clear is safe to use. So be careful with that. Okay. So in response to a question that was asked about one of the explorations involving creating a matrix of random numbers between -1 and 1 instead of 0 and 1. Here, the rand command generates numbers that are uniformly distributed in the interval 0 to 1. So we see an example of that here. And if I were to use this command several times, we would see different random numbers each time. Although, if you were to generate a random matrix and then close your MATLAB session and then go back in and create that random matrix again, you would see the same random numbers because MATLAB's random number generator starts with the same seed every time the application is opened. So you would see that same sequence generated. You could always use our Matlab commands, which again I won't get into here, to change the seed so you get a different sequence every time. But sometimes having the same seed is helpful, where you want something that's random but still want to work with the same sequence. For instance, if you're testing something and trying to get it to work, and you want to know what data to expect. Okay. So the problem, and this is actually exploration 1.2.5. We want to change the distribution of random numbers from -1 to 1 instead of 0 to 1. So that problem calls for a linear transformation of the interval 0, 1 to the interval -1 to 1, involving shifting and scaling. So you figure out what transformation that is, like on paper or in your head, and that's what you would apply to this random matrix to get the right distribution. Now, one thing I want to illustrate about the kind of operations you would perform for doing that, I mentioned in the exploration itself using the ones function. So if I take this matrix that I've created here, it's a 3 by 2 matrix, I want to add 10 to every element, like I've shown here. That means I'm adding a matrix that contains all 10s. So I could type out such a matrix, and if it's 3 by 2, that's no big deal. But what if the matrix is much larger? I don't want to type out all those 10s. So what I can do is use the ones command to create a matrix of whatever size I want containing all ones, and then just multiply that by 10, and I get a matrix of all 10s that way. So now I can take my random matrix from before, A, and my matrix of all 10s, B, and add them together, and now I have random numbers between 10 and 11. But I don't have to do it this way. I can also just add 10, like that, and get the same effect. And the reason why is MATLAB interprets this operation as not adding the scalar 10 to the matrix A, which would be a mathematically invalid operation, but rather interpreting this as that I intend to add a matrix of this appropriate size, 3 by 2, that has 10 as every element, and then add that. So that's convenience. Which reminds me of another example of MATLAB's permissiveness. If I create a random column vector, so a 5 by 1 vector, 5 rows, 1 column, and also a row vector, 1 row, 5 columns. Now, if I were to subtract these, in older versions of MATLAB, that would be an error. But not anymore. What MATLAB is apparently doing here is subtracting every element of U from every element of V and creating this matrix, which personally I object to this behavior. I think it should be an error. But I guess maybe people asked for this feature that they thought it was convenient to have. So that's the way it behaves. So be careful about that. Because if the vectors U and V are very large, this could be a very expensive, time-consuming operation, as I've discovered the hard way. If I really want to subtract these vectors in the usual way, I should make them both row vectors, both column vectors. Here I've taken the row vector V and made it a column vector by taking taking the transpose and subtracting them. Now, okay, this is a response to a question that was asked about the persistence of variables. So if I assign a value 10 to x, then if I use that in another expression, then the value of x will be 10 in this expression as well. So in this case, I get e to the 10. But what happened was, if you get an error message along the lines of unexpected expression, that means a syntax error. So in that case, it was a matter of forgetting to use the asterisk for multiplication. Now, sometimes MATLAB tries to help you figure out your errors. So I have a variable lowercase x from before, but not an uppercase x. So if I type 4 plus uppercase x, it gives me an error message, but then it tries to help me out and ask if this is what I meant, because I do happen to have a lowercase x handy. So then I can just go ahead and run that command instead. So that's one other behavior of MATLAB to be aware of. This is a throwback to last Thursday's class, where I had some difficulty with plotting. here I create a vector of equally spaced values between 0 and 1. And I wanted to make it a column vector, so I take the transpose again. And I go ahead and, like I did before, plot e to the x for these x values using a red dashed curve, and then e to the x sine x for these x values using a magenta dotted curve. And Matlab was again causing difficulty. It was not letting me select whatever portions of a plot that I, whoops, sorry about that. Portions of a plot that I wanted. Sometimes if I shut down Matlab and restart it, then it behaves correctly. But this is something very frustrating and buggy about Matlab right now. So I tried to do that again, and it didn't go very well. Okay, so in response to a question about exploration 1.2.1, part 3, what I have in mind is you could just use pi normally to refer to pi, but for the sake of a problem, again, to get accustomed to working with the different mathematical functions that Matlab offers, I don't want to use this pi for pi, but to actually use an expression for pi that you get by taking this equation, solving it by hand, and the resulting expression would involve one of Matlab's functions that you get as a result of solving this equation. Okay, now I'm giving some preemptively giving you some information about exploration 1.2.11 that involves complex numbers. Generally students don't have much experience with complex numbers, so I want to give some fun facts about them. So here we have a complex number, u plus iv, where u is a real part, v is the imaginary part. Mathematically, this is how they're represented using capitalized RE and capitalized IM. That's a convention that most textbooks use, and often in a fancy font too. The Matlab functions that are used to extract real and imaginary parts, I have down here. Real z and imag of z gives me the real and imaginary parts, which are themselves real numbers, of this complex number z, which I've formed as u plus iv. So I've created two random real numbers, formed a complex number this way. Matlab recommends using one I instead of I for the imaginary unit, square root of -1. And the reason for that is I by itself could be used is ambiguous. It could refer to the imaginary unit. It could also refer to a variable I. So Matlab tells us that it's more efficient to use one I when referring to the imaginary unit because that removes the ambiguity. So either way would work, but this is what's recommended. You can also represent a complex number in polar form, z equals r times e to the I theta, where r is like the magnitude or absolute value or complex modulus of the complex number z. And that's the square root of real part squared plus imaginary part squared. And then the angle theta satisfies this equation, that the tangent of theta is the imaginary part over the real part. Similar to polar coordinates, r and theta, used to represent points x, y. In the xy plane, here we're representing complex numbers in the complex plane, where the real axis is the x-axis and the imaginary axis is the y-axis. Now, if I look at my variables using the whos command, that gives me information about them, like the size of your matrices or vectors, and also how much storage they take up. Every double precision floating point real number occupies 8 bytes of space. So here we have a matrix A that has 6 elements in total, so it takes up 48 bytes. Whereas Z is a complex number, just one number, it takes up 16 bytes, and it's noted here that it's complex. 8 for the real part, 8 for the imaginary part. So if you have a matrix of complex entries, even if only one of the entries is complex, Matlab will store two matrices, one that has all the real parts and one that has all the imaginary parts. But we try to avoid complex arithmetic if we can because, for two reasons. One, double the storage. Second, at least double the work for arithmetic. For addition and subtraction, you have to add and subtract the real and imaginary parts separately. And then multiplication and division are even more expensive. Now, if I take a complex number z and square it, we're accustomed to square of a number being a positive, or at least non-negative real number, but square of a complex number is generally complex. On the other hand, if I multiply z, not by z again, but by its complex conjugate, so the complex conjugate of a complex number is where you negate the imaginary part, then we get a non-negative real number. And to see why, if we work out what that is, z is u plus iv, z conjugate is u minus iv. So if I expand that, I get these cross terms canceling out, and then I times v quantity squared is v squared times minus 1, and that minus 1 cancels with this minus 1 to give me a plus. So I get u squared plus v squared. In other words, in terms of the terminology I gave earlier, complex number times its own conjugate is the magnitude or absolute value or complex modulus of z squared. Okay. Now, this brings to mind, this is relevant to exploration 11, the importance of using a proper transpose. So if I create a 2 by 2 matrix of complex numbers here, and I take the transpose, or I think I'm taking the transpose using this single quote or apostrophe, I get the real parts negated. That's because this doesn't mean transpose, it's Hermitian transpose, often written in textbooks, including my own, as z superscript h, as opposed to superscript t for transpose. So Hermitian transpose is the transpose and complex conjugate. So we see that the sense of rows and columns is reversed, but also the imaginary parts are negated. If I just want ordinary transpose without conjugation, that's z dot apostrophe. And we see that it just reverses rows and columns. It doesn't negate the imaginary parts. The reason why the default behavior with just the apostrophe is Hermitian transpose is generally algorithms and theoretical results involving a transpose for real vectors and matrices are generalized to a complex case using the Hermitian transpose, but that's required to achieve that generalization. There is an interest in what are called like complex symmetric matrices, but it's Hermitian matrices that are generally, in other words, a matrix is equal to its own Hermitian transpose as opposed to just ordinary transpose that tend to be more useful. Okay, and now just give you some information about exponentiation of complex numbers. So if I have a complex number in polar form and I want to raise it to the nth power, it's easier to work out in polar form, regardless of what the exponent n is, whether it's an integer or a fraction or whatever. So I end up raising the magnitude to the nth power. It's this ordinary real number exponentiation. And then I end up multiplying the angle of a complex number, t is short for theta, multiplying that by n. So e to the it is cosine t plus I sine t. So z to the n is r to the n times cosine t times n plus I sine t times n. So you're multiplying an angle by n. So if my complex number is I can write that as cosine t plus I sine t. And the question I put out there was, what is the proper t? What is the angle that gives us this? And that angle is pi over 2, or 90 degrees. Because cosine of pi over 2 is 0, so there's no real part. And sine pi over 2 is 1, so we get an imaginary part of 1. So if I want the square root of I, or I should say a square root of I express I in polar form, and then to take the square root, I can just cut the angle in half. So I have cosine of pi over 4 plus I sine pi over 4. So that would be, so the square root of I is square root of 2 over 2 plus the square root of 2 over 2 times I. Now if I negate that, so in fact I do square root of I, that is what I would get. But I can also negate this, I get the negative square root. So complex numbers have, you can think of it as, they're not really positive or negative square roots because they're not necessarily positive or negative numbers. But you can take a square root of it and negate it and get the, both the real and imaginary parts and get the other square root. And you can use this idea to get, nth roots of complex numbers. But keep in mind, a complex number has n distinct nth roots. And so if you look up, for instance, you can Google nth root of unity, you can see how to compute all n roots of a complex number. A couple other things about Matlab I want to mention related to numbers, or not really numbers in this case. If I take 1 over 0, now the limit of this expression as the denominator goes to 0 from positive values is plus infinity. So if I type 1 over 0, I'm not supposed to divide by 0, Matlab represents this as nth for infinity. Or I also have minus infinity, so you don't want to see that. And what's even worse is 0 over 0, which is the indeterminate form, it returns NaN for not a number. So if you see these in, if your code produces these, chances are you messed up badly. Okay, question was asked, how do I set values of several variables all on one line? Here's how you do it. You separate them by semicolons. Okay. Now, a little bit about the polynomials. I can represent a polynomial using a row vector of coefficients. So, for instance, for polynomial x squared minus 4x plus 4, I give a row vector 1, minus 4, and 4. So the coefficients from left to right of every elements of this vector from left to right are the coefficients of a polynomial from highest degree to lowest. So then if I take the roots, then I get the, because we have roots, which are just double root of 2 in this case. This is in response to a question that was asked about the first exploration. In that exploration, I don't want you to use a roots function. I want you to use the actual quadratic formula, again, for working with Matlab's mathematical functions. But generally, you can just go ahead and use roots, unless I ask for something else specifically for that problem. Now, a sort of inverse of roots is poly. If I provide the roots of a polynomial, poly gives me the coefficients. So sure enough, I get that polynomial back. It's going to produce a monic polynomial. In other words, a leading coefficient will be 1. Because generally, any multiple of a polynomial has the same roots. So to demonstrate how roots and poly are inverses of each other, I take roots 1, 2, and 3, form a polynomial that has those roots, of a monic polynomial, then take the roots of that polynomial, and sure enough, I get 1, 2, and 3 back. But it doesn't always work that way. So if I do, so here I'm just explaining what these functions do, and this will be in the diary that I'll post. So if I take roots of poly of 1 to 20, I expect to get 1 to 20 back. But I don't. This is because of round-off error, and this is a ill-conditioned problem. This is something I'll talk about starting next week when we get to Chapter 2. So this is kind of a preview of that. And in fact, if I do 1 to 50, it gets even worse. I expect the roots 1 to 50, but I get complex numbers. So, and most of the magnitudes are way off. So things went very badly in this case. Okay. Okay. Sorry, I want to check on. Okay, it looks like I've actually gone too far. So the videos kind of overlap. But I suppose it's not the worst thing in the world. So I'm just going to stop this here. And then I'll splice the other one on top of it. Okay, so I'll admit up front I've blown it very badly. And, well, apparently, since I'm pushing 50 and all, I'm becoming more and more forgetful. So if anyone wants to remind me in the future about doing this recording at the very, very beginning, just like you guys help with reminding me about doing a diary. So we need that. Now, when I am not doing Matlab demonstrations, I still want to do some sort of recording, even though it didn't go very well a week ago. One thing I actually did remember to take attendance. I'd forgotten to do that last time, but I actually figured out who was here anyway because I pretty much know who everybody is. Actually, yeah, now I do know who everybody is. Okay, so just some notes here for the sake of this diary. Okay, so roots of polynomial represented by P. Poly equals coefficients of polynomial with given roots. So presumably, roots of poly of x is supposed to equal x. And I say supposed to because it's not always true in practice. So for instance, now in this case, it worked out just fine that I have roots of poly 1, 2, 3 gave me back 1, 2, 3. But now I'm going to do roots of poly of the numbers 1 through 20. I'm not going to type them all out because I'm lazy and forgetful. So if I do 1 colon 20, that gives me the numbers from 1 to 20. And what I get is supposed to be 1 to 20, but as you can see, it's a little bit off. What? Okay. Yeah, I guess what I get for having such a large font. Oh. Yeah, so you can kind of recognize numbers that are close to 1 to 20, but it's only getting like really just 2 significant digits. Correct. Okay. Okay. And in fact, if I go a little further, 1 to 50, we get complex numbers. This is one of the problems with floating point arithmetic and something else I'll be talking about next week, badly conditioned problems, that there really is no accurate way to solve them. And the reason I want to bring this up is since there was a question about the quadratic formula, we're actually going to learn a second quadratic formula. So when you're doing these things on paper, the quadratic formula you learned long ago is just fine. But when it's a computer doing the work, there's actually 2 quadratic formulas that are needed to ensure the most accurate computation of the roots possible. Okay. All right. So if time permits, what I might do after class is have something more to record besides what I'm doing right now. So my apologies to the 1, 2, 3, 4, 8, 12, 16. My apologies to the 2 people not seeing this. Thankfully, there are only 2. Okay. All right. Now, one other thing I want to mention is in the editor here. This is the first script that I have. So around on page 19. Enter month year. So this is already reproduced in the textbook, but I have it here, where the user is prompted for the number of a month, and they're prompted for a 4-digit year. So using the input command does that, and then it will tell me how many days are in that month, taking into account if it's February, whether it's a leap year. So a few things I want to mention about this, because there are a couple explorations that call for modifying this. First, the spaces are important here because I'm creating basically a matrix of characters. And semicolons are used to separate rows. Each row has to have the same number of characters or it will give me an error. So that's why we have so many spaces here, except for September, which is the longest month name. This line, if I did all one line, it'd be very long. So I can put a ... at any point, and that ends the line. But it allows me to continue the statement onto the next line. So here, this statement's continued onto 3 lines because it's so long. Another thing I want to point out is, okay, I'm going to, okay. I'm going to cut that. I'm going to temporarily delete this to show you something that happens as you edit. First of all, now this code has a syntax error in it. So we see, literally, we see red up here. That means you have some syntax errors. But I want to show you what happens as I type. So right now I'm in the middle of an if statement. So as I hit enter to go to the next line, it's indented for me. So that's one thing that it keeps track of. But now I want to have an else. So if I type else, watch what happens. It automatically unindents. So it tries to be as smart as possible about indenting. But now I'm in another clause of an if statement. So I go to the next line and notice it's indenting again. So I'll put my comment back that I cut earlier. Oh, here it's indented wrong because of what I copied. So I can hit, this is a Control-I in Windows or Command-I on a Mac to do a smart indent. And then I'll go ahead and type in days equals 31. And then I'll type end, and notice it auto-indents again. Now, if I were to have messed up indentation, because proper indentation is not required by any means, but it can be helpful to better see the structure of your code, especially if you have a bunch of if statements and for loops, etc. And if I purposely mess up the indentation, but then what I do, and I do this from time to time, especially when students send me code because it's a mess, I select everything, so Control-A on Windows or Command-A on a Mac, and then if I do this Command or Control-I, now on what I've selected here, it will smart indent everything. So that's one thing to keep in mind when you're editing. Also, this is something that came up with a student working on one of these problems. Here I have, what I'm doing here is, disp is used to display whatever, whether it's a matrix or a number or a text string. Here I'm building a text string. So the whole string is contained within square brackets. You can think of it as like a row vector of characters. And so what I have here is so first I have a variable month name, which is also text. So I put it in there first. And then I want the month to be followed by a comma. So I put a comma and a space in quotes, just so it looks nice. And then year is a numeric variable. So I pass that to the function num2string. And so that gets put in next. One thing I want to mention, though, the spaces between these are important. I had a student forget to put spaces in between like I have them here, and it gave him errors. And then I have more text. So after the year is printed out, then I have a space, then the word has, all in quotes, then a number of days, and then some more text to close it out. And then the closing square bracket ends a string. But I want to call your attention to the spaces in between these items. You can also put commas. It's so for separating entries in a row vector, you can use spaces or commas. Commas might be best because at least it's unambiguous. Because if you have mathematical expressions of spaces, Matlab might interpret them incorrectly. Also notice in if statements, like also in C and C++, double equals is used for comparison as opposed to a single equals for assignment. And the same and or operators are used in C and C++ are used in Matlab. So a double vertical bar for or, and then there'd be like a double ampersand for and. Okay, so if I were to run this, I would type in the name of a script, enter month, year at the prompt, and then I'll fill in, okay, so for instance, September 2017, and then it'll tell me that it is 30 days. So based on how I built up that string on the last line. But if I do, for instance, it's kind of annoying how it puts that input in the command history. I'd rather it not do that. February 2016, that was a leap year, so it accounts for that. It has 29 days. Okay. Exploration number 12 involves using this exact same script, but then adding things onto it. It already asked for a month and a year. You'll have it ask for a day as well, where you tell the user for a specific range of what the day should be, like based on the month they entered. Like for instance, if they entered February 2016, it should prompt for days 1 through 29. It should be smart enough to do that. And you do that by building up the prompt as a text string, just like it's done in the last line here. So in exploration 12, you can start with exactly this script, just give it a different name. It's a day and year.m. And then instead of printing this out, you would use this information to prompt them correctly for how many, for what day they want, and then you can go figure out the day within the year. So for instance, like I said in the problem, February 15th would be day number 46. December 31st would be 365, unless it's a leap year, in which case it's 366. And so you could use like if statements to try to figure out, have it figure out what day within the year it is based on what month they entered. And exploration 12 is actually a setup for one of the very last problems. Actually, it's the last problem, number 25, that's used to figure out what day of a week a certain date occurred on. So if you had them enter August 24, 2017, it should correctly return that it's Thursday. That one's kind of a pain, which is why one of you guys get an earlier start on it than you generally have. Okay. Now, so we're still going to have one more class period to do anything Matlab-y. Although we'll, yes?
How do you add on to a diary you've already in? Can you?
Yes, you can. Well, so actually, yeah, I mentioned that last time, where if you do diary off and then you come back to it later and do diary again with the same file name, it'll by default append. Yeah. Unless they change that too, but... Okay, good. Yeah, because you never know when they change things. But... was there another question?
Just in general, when you've got a problem that asks us to type the help command and work through it and see how the functions work,
yeah.
Do you want us to backspace all that out of the text file before we submit it to you, or do you want us to leave it in there so that you can see that we actually did it?
I genuinely don't care.
Okay.
All right. Yeah. So as far as like whatever diary you turn in or scripts you turn in, so as long as I can basically follow what you're doing, because of course it's not going to be pleasant to have to read through 21 of these things. That's how many people are in the class, but and who knows, maybe I'll regret giving you so many problems by the time it's over, but we'll see. Okay. In the final 3 minutes, do we have any other questions? Okay. All right. So come Tuesday, I'm hoping to see a lot more questions, a lot more progress on these things, or at least, if having difficulty making progress, more questions about what's going on. And of course, always appreciative for any mistakes that are found in the book. Although I'm hoping that there are not too many. Okay, so I'll post what meager video I have and anything else I do after class. So. Okay, diary off.